discuss about the important aspects of Coulomb's law. So the last classes we discussed about the Coulomb's law. We have to consider two charges Q1 and Q2 in between the distance R. So Q1 exerted a force on Q2 is F21. Q2 exert a force on Q1 is F12. And the unit vector of F21 is R12. The unit vector of F12 is R21. Okay. So what are the important aspects of Coulomb's law? So the first thing, that means the first important aspect is, so Q2 exerted a force on Q1. Q2 exerted a force on Q1. That force lies along the joining of two charges. That force is always lies along the line joining of these two forces. So இந்த ரெண்டு force ஓட line joining ல தான் இந்த Q2 Q1 மேல exert பண்ற force இருக்கும். Q2 Q1 மேல exert பண்ற force இருக்கும். Q1 Q2 மேல exert பண்ற force இருக்கும். ஓகேவா? So அதுதான் first important aspects. So now the Q1 exerted a force on Q2 is F21. So the unit vector of F21 is R12. Unit vector of F21 is R12. So for F21 is equal to, we know, K Q1 Q2 by R squared R12 cap. R12 cap. So likewise, the direction of R12 is this way, but the direction of R21 is this way. So R21 is opposite direction of R12. So I have to write this R12 is equal to minus R12. R is equal to R21. Okay. So R12 is equal to R21, but the direction of R21 is opposite direction of R12. Opposite direction of R12. So before that, I have to write likewise. So I have to write like this. So minus R12 cap is equal to R21 cap. R21 cap. So this is the correct formation. This is the correct formation. So this is the first important aspect of Coulomb's law. And the second important aspect of Coulomb's law is the value of K. The value of K. So the value of K is equal to 1 divided by 4 pi epsilon naught. 4 pi epsilon naught. So this 4 pi mentioning the charges or a spherical nature. Charges are a spherical nature. So this 4 pi is indicated as charges on a spherical nature. And this epsilon naught is related to a medium. Is related to a medium. So which medium we have to use? Which medium we have to use? So this epsilon naught is represent the medium. That means, so the permittivity of medium. Permittivity of medium. Okay, here we have to use vacuum. That means a free space. Free space means it doesn't have any air molecules. So this is a permittivity of vacuum or free space. So this epsilon naught is the permittivity of free space. Permittivity of free space. Okay. So now they give the value epsilon naught is 8.85. Okay. So the medium of, so that means the permittivity of vacuum is 8.85 into 10 to the power minus 12 Coulomb square per Newton per meter square. Coulomb square per Newton per meter square. Okay, the value of K is, if we substitute the values of pi, the value of pi is 3.14. The value of pi is 3.14. Okay, we know this is the 4 constant value. Epsilon naught value, we know 8.85 into 10 to the power minus 12. So you substitute all the values and multiply, and you divide this value, and we get the value of K. So the value of K is 9 into 10 to the power 9 Newton meter square per Coulomb square. Newton meter square per Coulomb square. So this is the second aspect. So the third aspect is, so the magnitude of force. The magnitude of force F21. Okay. If we find out the magnitude of force, we have to consider the Q1 is 1. Q1 is 1 Coulomb. Q2 is also 1 Coulomb. Q2 is also 1 Coulomb. So if we substitute, we know the value of K. K is 9 into 10 to the power 9. So 9 into 10 to the power 9. Also we have to take R is a 1 meter. Also we have to take R is a 1 meter. If suppose 1 Coulomb of charge and 1 Coulomb of charge, 1 Coulomb of charge is placed at the distance of 1 meter. So the magnitude of forces, so this is the value of K, and what about the value of Q1? Q1 is 1, Q2 is also 1, and divided by R squared is also 1 square. So here we have to take a magnitude. So the vector is voidable. Vector is, if we take a magnitude, the vector terms are not come. Okay. So now the value is 9 into 10 to the power 9 Newton. 9 into 10 to the power 9 into 10 to the power 9 Newton. So in practice, the 1 Coulomb of charge is not applicable, and the 1 Coulomb of charge is equal to a 1 million ton. 1 million ton. So 1 million ton is equal to a 1 Coulomb of charge. So in practice, we cannot use the 1 Coulomb of charge. We cannot consider the 1 Coulomb of charge. So we have to, in day-to-day life in electrical, in day-to-day life in electrically, we have to use the value of charges, microcoulombs or nanocoulombs. Microcoulombs or nanocoulombs. So we have to call this symbol as mu C. So this micro is defined 10 to the power minus 6. The value of micro is 10 to the power minus 6, and the value of nano is 10 to the power minus 9. 10 to the power minus 9. So this is mu C N C. Mu means micro coulomb, N means nano coulomb. Micro means 10 to the power minus 6, nano means 10 to the power minus 9. So fourth important aspect is permittivity. So in vacuum, we have to use this value permittivity. Permittivity of vacuum or permittivity of free space. So if we considered a medium, air medium or water medium or glass medium, if any medium we have to choose, we have to use the symbol as epsilon. This is epsilon naught, this is epsilon. Epsilon. Okay. So in medium, if we consider two charges placed at a medium, we have to use this epsilon. So the force equation changes likewise. K, that means 1 by 4 pi epsilon. 1 by 4 pi epsilon Q1 Q2 by R square. So this equation changes likewise here. So before that, in vacuum we have to use here a epsilon naught. So in medium we have to use here the epsilon. Here the epsilon. Okay. Then we have another one, relativity, that means the permittivity term, that is a relative permittivity. That is a relative permittivity. So epsilon r is equal to epsilon by epsilon naught. Epsilon by epsilon naught. So if we consider these two mediums, one is the medium, that means air medium, glass medium likewise. Another one is the vacuum or free space. We have to use the relative permittivity. If you want epsilon, then you move the epsilon naught here, or if you want epsilon naught, and then you move epsilon r here. Epsilon r here. Okay. So the relative permittivity of vacuum or air, the relative permittivity of air or vacuum, we have the value is equal to 1. We have the value is equal to 1. So other than medium is greater than 1. The relative permittivity is greater than 1 for other mediums. 1 for other mediums. So in air medium or vacuum is equals to 1. So the next important aspect is, before that we have to write the force equation in F21. So now we have to write a force equation in F12. So F12 is equal to 1 by 4 pi epsilon naught Q1 Q2 by R squared into R21. Yes. If we use F21, the unit vector is R12. F12 means unit vector is R21. These two terms only, this one term only change in the equation. Okay. Already in the first aspect, we know the value of R21 is equal to minus R12. So now we go to substitute this value minus R12 for R21. So now the equation becomes 1 by 4 pi epsilon naught Q1 Q2 by R squared into minus R12. So now I have to put the minus in front of the equation. So it is equal to minus 1 by 4 pi epsilon naught Q1 Q2 by R squared R12. So now this value is for F21. This value is F21. இது வந்து F21 ஓட value. 1 by 4 pi epsilon naught Q1 Q2 by R squared into R12 is the equation of F21. Now I have to substitute F21 here. So F12 cap is equal to, here we have the minus F21 vector. So the both are in opposite direction. F12 and F21, the both are in opposite direction. So this aspect is giving the direction of these two forces. Okay. So the another one aspect is this Coulomb's law, and these conditions are only for point charges. True only for point charges. So point charges க்கு மட்டும் தான் நம்மளால இது எல்லாத்தையுமே யூஸ் பண்ண முடியுமே தவிர continuous charges க்கு we cannot use this. So thank you.